All right, welcome back. This is Statistics Chapter 2, which is about presenting data. And again, I'm in the wrong spot as per usual. Let's try there. Okay, so we start out with something called frequency distribution. And the frequency is the measure of each variable. And that's going to change depending on what you're measuring, what kind of a scale you're using, and how often you're using it. Relative frequency is the number of times an observation occurred divided by the total number of observations. So for example, in our bed baths, if we're monitoring our bed bath compliance, we're looking at how many times somebody actually gave the bed bath versus how many times they should have. Same thing is true for hand washing. How many times did somebody actually wash their hands before they went into the room versus how many times could they have, or how many opportunities did they have? The cumulative frequency is the number of observations with a variable less than the maximum value. So for example, 76% of skills days participants ranked their satisfaction at 7 out of 10 or higher. That doesn't mean that 7 out of 10 was the score that they all chose. They may have scored an 8 out of 10, a 9 out of 10, or a 10 out of 10. So a cumulative frequency is adding those percentages together to come up with a final amount. The key here is that 76% of people thought it was satisfactory. Okay? And you can kind of see some examples of some of those things over here. So percentages are partial numbers divided by the total and then multiplied by 100. You guys know how to do percentages. That's not new math, but it does play a huge role in statistics. So the percentile rank is the percent of observations lower than a score. So for example, if your test score was greater than 75% of the class, it's at the 75th percentile. Charts, all right, so we have a lot of data, but data doesn't mean much unless we can put it in a way that makes it easy to understand. So there's a lot of different options here, and the one that you're going to choose is really dependent on the type of data that you have. So a bar graph, for example, is best for nominal categorical data. So if you recall, nominal is named data. So it's distinct answers with no order. We're not ranking anything here. It's used for ordinal data. The bars need to be by rank. So the visual to the side here is actually ordinal data. We have a none, a mild, a moderate, and a severe. So we can clearly rank that, right? There's a curve happening here. So you can also use a pie chart to describe some proportions, but again, it depends on what you're describing. If 50% of people like pepperoni on their pizza and 50% of people prefer cheese, that's better displayed in a pie graph necessarily than a bar graph. Histograms are basically bar charts with data on a continuum. So the space is removed to make the data visually closer. So for example, this bar here would actually be over here. All right, charts can include line graphs. You guys have all seen line graphs. We don't need to talk about that. But they show continuous variables that change over time. That's the whole point of having a line graph, is to demonstrate time versus change. Scatter plots are a little bit different, and it's something that we can use pretty often in healthcare. It represents the variety of data and the relationship. So it makes it easy to see general trends in positive relationships. Example, the relationship between height and weight. Kiddos, as they grow up, are going to fall on a continuum, but it's helpful to see all of the data and how it kind of correlates with time. So it helps identify those outliers. If your kiddo is severely underweight or severely overweight, we should be able to pretty clearly see that on a scatter plot. So that's what you see over here to the right. It's the amount of time that passed is right over here, and then the dinner, the lunch, and the total bill. So what we're trying to see here is what time do people come in, how much money did they spend, and is that versus dinner versus lunch? So you can see here, there's a lot more little squares right here in this zone here. So the total bill was only about $10 to $20, all right, probably right in the 15 range. They didn't spend very much time here. It took them less than, I would assume that's hours, or I'm sorry, that's actually tip. So their tip was $2. So because their bill was less, we can expect that their tip would have been less, right? So Here, we know if they spent about $10 to $15 on their bill, they tipped about $2, and that was more likely to happen during lunch. So that's what a scatter plot can show you. It's kind of the generalized proportions of things, but also these outliers. So one person up here had a $50 bill. They tipped 10, which is relative, but that was a dinner. Okay, that's not the norm for this restaurant. So that would be, maybe they had 6 people or 8 people when ordinarily 2 or 3 people come in at a time. We can also use box and whisper plots, so that also helps us show outliers. And that's important when we're talking about certain disease processes, likelihood, not likelihood of having a disease, things like that. It helps us determine our central values, and it usually uses quartiles. So here we have a whisker plot. So the lowest observation starts here, the highest observation starts here. So again, we need data that can be ordered in that way. And then the box is kind of the median, which is sometimes in the middle, sometimes not. The lower quartile, and the higher quartile. So this box here actually can move back and forth depending on what the actual median number is. And we're going to talk about that here in a second. And that would bring us to chapter 3, which we'll start up here again in a minute.